Hey, we unfortunately got interrupted because my browser crashed and because we were on screen share. I didn't see it in time. So could someone give me a very brief heads up where we were? Because unfortunately now the live chat is gone. So this is not super handy. But yeah, I hope you see this. And yeah, give me a second to tweet where the new live stream is, okay? Damn it. Okay, so I hope that my browser won't crash again, so that we can actually finish this. And yeah, I hope I can pick up the right part where you lost me. And if not, please correct me. I'm trying my best staying here and being in the right part. So yeah, I think we went through the interpretation of the model output, and I hope this was transmitted. But what might not have been is the model comparison. So in order to find the best model and compare which of your two models or multiple models performs best, you're running an ANOVA between the two models and compare model performance. When you run this, you get an output which looks like this, where you compare the performance of two models with each other. In this, it's pretty clear that Model 2 performs significantly better than Model 1, and that the interaction I added has a significant positive effect on the overall model performance. If this is not the case, that you have here a significant effect, but you still need to decide on a model because it's two factors you have hypotheses about and you're playing around with other models. Another thing to look for is the AIC. I always forget what this stands for, but you want this to become smaller. So here we have, it ends at 43, here in 34. So the second model performs better on the AIC. So even if this would not be so significant, you would know that the second model describes your data better. If you want the p-values and you want to estimate p-values, I'm always doing this also by estimating degrees of freedom and estimating the p-values. I haven't played around with the package Stacy introduced earlier, so this is new to me and I can't explain you much about it yet. But it's probably worth trying. But this one also works. Basically, you just run this line of code here. This is the p-values for your model, and you do an internal model comparison which estimates the degrees of freedom and the resulting p-values. If your outcome variable is not a rational scale with where a 10 is twice as high as a 5, but it's more like a questionnaire, you want this to be a chi distribution, or you want a chi-test. If you are modeling reaction times or any other natural number, then you want this to be an f-test. The output of this looks like this, where you have a list of all the factors in your model, your chi-square value, the degrees of freedom, and whether it's significant or not in your model, and whether you have good effect, whether you have significant effects. So that's that. Now would be a good opportunity to ask questions, and yeah, maybe just for the visualization of the data, I'm also plotting it for you. You can run this later. No? Yes? So this is how the data would be distributed. And there you can see that the front or back vowels in red and blue here do not seem to have a very big effect between rater, do not seem to have a big effect for female faces, but do have an interaction effect of gender of the rater when you look at male faces. So far to this. If you want to read more about the study, you are welcome to read a preprint. And here we're back. And you are welcome to ask your questions. And I know this is very unfortunate that this is now a bit split up over 2 videos, but yeah. So Bill is asking whether there's a way to know if including random effects is helpful or not based on the variance explained. Helpful or not? Helpful or not? Oh yeah. Basically, I would. Do you want to take this?
Well, I think this is what you were just doing, right, with the model comparison. So you could have 2 models that are identical, except that in one, you only have a random intercept for the thing that you're interested in. And in the other, you have both a random intercept and a random slope. And then you can compare these 2 models using the ANOVA method that Franziska already went through to determine whether the version with the random slope is kind of a better fit for the data. I would also look at the papers that have been published very recently, especially by Douglas Bates. We can link those in the blog afterwards because they talk specifically about how to do this in a way where you're not sacrificing power, but you're also minimizing your type 1 error rate. So this is probably the best resource for this kind of question.
So yeah, I hope we took you a bit of the fear of using this and also using R, because R can be really complicated for several analysis and sometimes looks very intimidating, but actually doing linear mixed effect models is one of the easier things you can do in R. If you have questions, feel free to email me or comment on this video, and also on my blog part, on my blog website, which is storiesandthebrain.com/academic-crisisline. I will post a summary with more links and information and material to other things. So yeah, I hope you liked that, and I hope you found this helpful. I'm very sorry that that I had a browser crash and this video got interrupted. It's a bit unfortunate, but that happens if you're live streaming. So it's part of the show. Yeah, I'm planning to give my next live session on February 6th, which is in 2 weeks. And at the moment, as it looks like, I'm either going to talk about how to stay on top of research findings using different tools and always knowing the new advances in the field, or alternatively, something else you're voting for, and I'm going to decide next week. So make use of all the information which is on the bottom of the original video, where all the links have been posted. Vote for what you find interesting, and I hope to see you back soon. Have a good day.